This is a great opportunity for you to meet Yale graduate students, those of you who are prospective students. I apologize to the folks in the corner. That tree, even you'd have about a 3-degree angle on the... This is a great opportunity for you to meet Yale graduate students, those of you who are prospective students. I apologize to the folks in the corner. That tree, even you'd have about a 3-degree angle on the screen, but with the tree, you're even worse. But what I'm going to tell you about is Yale chemistry students who you won't be meeting during visiting days. For example, the class of 1913. When they'd have these class pictures taken, they would chalk things on the walls. For example, up there at the top, who in the hell wants to be a chemist? Or over here, we're the guys that put the mystery in chemistry. Well, it started with Benjamin Silliman, who knew absolutely nothing about science, not only not about chemistry, but not about science, when he was asked to be the professor of natural science in 1803. So he took a year to try to learn some before he started. This statue, you may have noticed, it's out in front of the chemistry building. It is said of him, he took a certain justified pride in his cleverness at small things. He had his lab down in the basement of the Lyceum, which wasn't an optimum place for the lab because everything got moldy and wet and so on. And ultimately they moved into the former dining hall, the old laboratory from 1820. It lasted till 1888. He did things like endorse commercial products. He said, having seen experiments made and also performed them myself with the India rubber prepared by Mr. Charles Goodyear, who's buried about 4 blocks over that way, I can state that it does not melt, but rather chars by heat. It does not stiffen by cold, but retains its flexibility with cold, even when laid between cakes of ice. But the real chemistry, I think, started. He was more of a popular lecturer, Silliman. John Pitkin Norton was a student, not a formal student. He never got a degree, but he studied in Silliman's lab. And it was said of him Latin and Greek were his especial aversion. He went to Edinburgh to study in the Agricultural Chemical Association laboratory in the 1840s for a couple of years, and wrote a work called On the Analysis of the Oat, 1845, which has 39 tables containing hundreds of accurate, minute analyses from different parts of the plant at different times in its development. And for this, he got a 50-sovereign prize from the Highland Agricultural Society. But he came back and became professor of agricultural chemistry and of vegetable and animal physiology. And then later he preferred professor of analytical and agricultural chemistry. So agriculture and analysis were where chemistry was at in those days. And he had a partner, Silliman's son, Benjamin Silliman Jr., who was 6 years older. So notice he became a professor at 24. Silliman was professor of chemistry applied to the arts. That doesn't mean the fine arts. It means the art of manufacturing things and stuff like that. So they established the 4th department in the university called Philosophy of the Arts. Philosophy means science and art means making things. So there was also theology, medicine, and law as faculties. And the corporation of the university wasn't too eager to have them. They consented to rent them the president's house. So these 2 young guys had to be the school. They had to pay rent to have this building. They had to buy all the stuff for the lab and so on. We still in the chemistry department have the table, marble table, on which they did analyses. So they established the School of Applied Chemistry in 1847, except that Benjamin Silliman took off, leaving John Pitkin Norton holding the bag. And he just couldn't take it. After just a few more years, he expired. And when you walk into the chemistry building, you see these names engraved there. And one of them is John Pitkin Norton, who you can see expired 6 years after he became professor of chemistry in 1852. So he, on his deathbed, he said, "My apparatus and books in the laboratory I wish given to the college, if the department shall be continued. I hope it will be kept up. It has cost me a great deal of labor." So, 1852, what's going to happen to science at Yale? Well, Benjamin Silliman came back from the medical school in Louisville, but he was in the college, not in the scientific school. So he was sort of irrelevant. Although you'll see as you go into the chemistry building, if you look to the left, there's this bronze plaque about his doing the analyses that were the basis for Drake's drilling for oil in Titusville, Pennsylvania, which was the start of the modern petroleum industry. But who was it that saved Yale's chemistry school? It was this guy, John Addison Porter, who started this in 1852 as professor of analytical and agricultural chemistry. This was after teaching rhetoric for 2 years at Dartmouth and then going to Germany to study with Liebig and Gießen for a couple of years. But the important thing he did was in 1855 to marry Josephine Sheffield, because Josephine Sheffield was the daughter of Joseph Sheffield, Joseph Earl Sheffield, who was started in Mobile, Alabama. He was from New England, but he went to Mobile, Alabama, and was a big operator with cotton sales and so on. And then he came back and founded a canal and then railroads. The Rock Island Line, which you know of presumably, was established by Joseph Earl Sheffield, and the New Haven line. So that was his father-in-law. So his father-in-law bought this house and changed it into this house, right, which is down on Hill House Avenue, just over this direction, a couple blocks. And then he bought his son-in-law South Sheffield Hall, a place where you could do chemistry. And there's a monument there that says that that's where it stood. And then he expanded it and put up this tower. That thing is an observatory. It doesn't look like a dome because the telescope in it can only rise 15 degrees from the horizon. It's a little bit limited in its scope for astronomical observation. But up the street a few things was New Sheffield Chemistry, which was built for chemistry in 1895, and which is where all these old group pictures were taken, or almost all of them. Then along came Samuel W. Johnson, professor of theoretical and agricultural chemistry from 56 to 96. And he wrote, essays on manures, peat and its uses, how crops grow. Here's a copy of How Crops Grow. It's not hard to get because it went through something like 18 editions. This was a big deal in the 19th century. And he was the excuse. He became a member of the National Academy and founding director of the Connecticut Agricultural Experiment Station. But he's the reason that Yale became the land-grant college of Connecticut. So they got federal money until he died and the farmers revolted and sent it up to Storrs to establish a dominant basketball program. So then Oscar Dana Allen was professor of agricultural chemistry and metallurgy. Metallurgy was a big deal with the arts, of course, in that time. And it was said of him, he determined, he was from Maine, where there was a mine where they got ore for cesium. So he determined first to determine an accurate atomic weight for cesium. And it was said of him, to all those who came to know him well, and knowing him, forgot or overlooked his peculiarities, he was an inspiration. Okay, so this is the first U.S. PhD diploma in physics in 1861 to Arthur Williams Wright, and the first PhD thesis in engineering was this one, handwritten. You notice it's on the form of the teeth of wheels in spur gearing. And the guy that did this was very innovative. He had other developments too. This was a picture from that thesis, and careful analysis. And here was the design of a braking system for a railway car, which you see is from 1866. And in the other corner, you can see who it was that did this. It's J. Willard Gibbs, who now is known on a postage stamp, one of the few American scientists on a postage stamp. And that diagram on the postage stamp is something that he could envision quite easily in his head, right? But nobody else could. So here's a model that was made of it in 3D so other people could appreciate it. And that model, which plotted, it's a three-dimensional graph, right, with energy, volume, and entropy. What weird coordinates to plot. But that plaster model was made by James Clerk Maxwell in order to try to understand it, and it's on display across the way in the physics department if you want to see it. But we heard about stereochemistry, and here's one of the first really clear books about stereochemistry. And it was written by Charlotte Roberts, who was the first woman to earn a Yale PhD in chemistry, and in the class of the first women to earn PhDs altogether at Yale. And I suspect in the United States there's one woman got a degree in Germany in chemistry before, but I don't know of any earlier ones in the U.S. Charlotte Roberts wrote a really good book. If you can look at that if you want to. And it was said of it, it is the clearest exposition of which I have knowledge of the principles and conditions of stereochemistry. So this was a class in 1898. And one of the most prominent people was Henry Lord Wheeler, who was an instructor at that time in organic chemistry and soon to be professor. He was born in Chicago in 1867 and got his degree with Comstock, the guy here with the bow tie, in 1893. Then he went to Munich to work with Thiele on pyrimidines, and then he was quite wealthy. He had a private lab in Chicago before he came back to Yale. This is a picture of him, which I went up to check. It's not in the front hall. The renovation has moved it into some closet someplace. I don't know. But anyhow, here's Henry Lord Wheeler, and this is Bayer, and there's Thiele with whom he worked in Munich. So they did a lot of publishing. This 102 is the number of this paper. They numbered all of the papers from Yale sequentially. So it's not just by him, right? So it's on condensation products of pseudothiourea. So there's a pseudothiourea, and you see you can condense it by losing ethanol and sodium hydroxide here to make that ring thing. And if you eliminate water, you get uracil. Okay, but also notice that had an H on there. If you put a methyl on there instead and did the same trick, right, then you could get thymine. Right? And in another paper about cytosine, they say Kossel and Steudel, working with a large quantity of sturgeon's testicles, got a new compound here with this formula, but it was not quite sure what the structure was. So these guys took the condensation product, changed the carbonyl to a chloride, and then chloride to amine. And then when they do their dehydration, they get cytosine. So these early studies of nucleic acids came from the basis came from Yale. And the person who did that last paper with Henry Lord Wheeler was this guy, Treat B. Johnson. Here are two papers from 1903 about cytosine. Right? So this is publications on pyrimidines. So all this work was in Europe, but suddenly Yale took off as a contributor of fundamental work in the area of pyrimidines. But Johnson it's best for us not to talk about what happened to Henry Lord Wheeler. We can discuss that privately sometime if you want to. But Johnson replaced him and worked on other things as well, like the preparation of antiseptic compounds. It says here, nothing appears to be definitely known as to how the antiseptic strengths would be affected by replacing methyl group with alkyl radicals or greater weight in resorcinol derivatives. So he did a systematic medicinal chemistry kind of thing here, starting with resorcinol itself, which has a certain antibacterial activity. You put a methyl group on, ethyl, propyl, butyl, right? Gets a lot better. So you might, I could ask a show of hands of what the next experiment should be. But the next experiment was not, in fact, done by him. It was done by the person with whom he consulted, the president of Sharp and Dome Pharmaceutical Company, who found that it maximized at hexyl. So this hexyl resorcinol was then the subject of a very important patent. And, in fact, it's still used as an anti-aging cream, I'm told. Right? But it was said Johnson's share of the profits was substantial. The business acumen he inherited from his Yankee forebears stood him in good stead, for this relationship led to the accumulation of a comfortable personal fortune from which we all profit, because he left money for the Treat B. Johnson Fund, which supports lots of activities in the department. He assigned 6 of his 15 patents to Sharp and Dome, which then became Merck Sharp and Dome, which then became Merck. But he did other things too, like the chemistry sets. Gilbert's chemistry sets in 1937 was edited by Treat B. Johnson, right? And then, of course, notice it's, I hate to say this, chemistry for boys. But it was really for boys, because you can see that the very first experiment is how to make an explosive mixture, right? And he says here, standing off at a suitable distance out of doors, being careful so as not to burn the hand or face, drop a lighted match on the mixture. But at the end, in italics, there's a caution: do not attempt to perform this experiment with proportions of chemicals larger than those stated above, and you can be confident that no boy in the entire country ever did it with larger quantities. But fundamentally, graduate school is not about faculty in the past. It's about graduate students in the future, about you. So let's look at some of the students. Okay. You'll have... So what you will have is some years of hard work ahead, right? But rewards also. Mark Hollingsworth, who's pictured here, got the ACS Nobel Laureate Signature Award for the best thesis in chemistry in the country, and you'll have fun too. So during graduate study at Yale, you'll learn to think clearly, to act quickly and decisively, to enjoy collaborating with outstanding scientists and the latest technology. So here's an example of that from August 2012, when there was a torrential rain and the drains backed up in the basement of Klein Lab. So, think clearly. You look down the hall and you see the water coming toward your apparatus. So you act quickly and decisively to use journals and Xerox copies to make a dam, and other equipment. But you also enjoy collaborating with outstanding scientists and the latest technologies to get rid of this. Okay, so like your predecessors, you'll produce a thesis. Here are a couple theses from the 1940s. The one on the left is the thermodynamics of hydrochloric acid in methanol water mixtures by John Bennett Fenn. And we can see what role this played in his later career. He said, the experiments were a boring chore with few redeeming features. The results contained no surprises and nothing of much interest to anyone, least of all me. My dissertation attested to the sterility of that project, consisting as it did of 45 pages of tables with only 3 pages of text. Although this first experience in original research shattered some illusions, my 3 years at Yale were a rewarding experience. I made many long-lasting friendships with both fellow students and faculty. So maybe we should forget that one and look at the other one, which is the ionization constant of carbonic acid by Raymond Davis. Now, I suspect that most of you don't know Raymond Davis, Jr., because he actually became a physicist, starting as a physical chemist. But here he is in 2002, getting the Nobel Prize for fundamental insights on astrophysics, especially the detection of cosmic neutrinos. Okay, shaking hands with the King of Sweden. So, what about poor old John Bennett Fenn? He got the Nobel Prize the same year, right, in chemistry, for his discoveries about soft desorption ionization methods for mass spectrometric analysis of biological macromolecules. So it's not done when you finish. It may be a high point in your life, but it's not the end of your life, your graduate years. Okay, like Peter Durbin, who got the National Medal of Science, whose PhD in '73 with Jerome Burson was again something quite different from what ultimately he did. We're not trying to teach people to become little midgets of ourselves, right, or even big persons of ourselves. We're trying to teach them to be scientists, right, to do their own thing. So he has ceased work after a few years at Caltech. He ceased doing thermal rearrangements. Now he's on the governing board of Yale, much to our gratitude. Or this guy, C. Malin Klein. Here he is, GlaxoSmithKline. That's Klein, and he built Klein Chemistry Laboratory and the Klein Biology Tower. Or here, this is about 1949 or 50, and here this woman is Pauline Newman, who got her PhD in 1952 with Harold Cassidy on oxidation potentials of hydroquinone monoethers. But then she went to work as a research scientist at American Cyanamid, but became interested in other scientific questions. In particular, this is a portrait of her now. She's the senior judge on the Court of Appeals for the Federal Circuit, which is the principal court for patents in the United States. And I phoned her up and asked her if she had advice for beginning people like you. And she said, my message for the graduate students is that a Yale scientific education can provide the framework for many aspects of satisfying service. But also Francis Collins, National Medal of Freedom, Medal of Science, director of the Human Genome Project, and he's been director of NIH since 2009. His thesis with Jim Cross in 1974 was semi-classical theory of vibrational inelastic scattering with application to proton plus hydrogen molecule. That's about as earthy a truly chemical process as you can imagine, proton plus hydrogen molecule. But he wasn't the only one that did that. Richard Preston, PhD 72, with Richard Wolfgang 2 years earlier, a theoretical study of non-adiabatic effects in molecular collisions, the proton plus hydrogen molecule, the same thing. And here we can hear him describe some of this.
My name is Richard Preston, and I'm a farmer from central Kentucky. I raise corn, soybeans, wheat, and milo. I kind of got to this operation a little bit differently than most people. When I was in high school, I thought I was going to be a professional baseball player, and that didn't quite work out. So I was awarded a scholarship in science and was able to pursue a career in chemistry, theoretical chemistry, where I went on to Yale University and received a PhD, and went on to Berkeley to do postdoctoral work. So I got to see a lot of the best universities on both sides of the country. It was really a great experience. But I always wanted to farm. And because I always wanted to farm, as soon as I was able to save up enough money from my job as a laser physicist at Los Alamos National Laboratories, I went back to the farm and started a combination hog operation and grain farm. And eventually, as the town came to my farm, urbanization forced me out of the hog operation. It was just not compatible with subdivisions, as one can imagine. And I became a grain farmer. I developed a system for niche marketing. I like to think of myself as the Victoria's Secret of agriculture, not Walmart.
So that's where we've been going for the last 100 years, right? Putting the mystery in chemistry. And we hope you'll join us. Whether it's in academia or industry, government, or law, or niche market farming, you'll make us proud. Now, okay, maybe we didn't choose the best visiting date for 2015. But when you decide to come, we promise you better weather, as you can see in these pictures. Good luck.